We're up. And do you want to monitor the stream? Thanks, man. So that's up now. This thing right there. So oh, and it's off. I wonder why. Maybe the settings are bad? Uh-oh. All right, we got eight minutes to debug this. All right, we'll diagnose this one first. Yeah, so it has an automatic title, and I just change it every day when I start the stream. All right, it says it's up now. There should be a new one starting. Okay, let me go get my laptop up there. Oh, man. I feel like the Terminator right now. Do you have headphones on? Do you have headphones to monitor the audio? Yeah, that'd be great. And Drew, if you want to monitor Piazza for concerns, that'd be great. Somewhere for me to plug in this.
It should be right under
there we go.
Kind of hard,
Missed that. There we go. Oh, perfect. Hopefully, let's see.
Switch sources.
Yeah. Say it's connected.
It is mirroring up
there. All right, that's good. Cool.
HDCP issue. Yeah, because if you're trying to record through something through HDMI through a Mac, it's HDCP. It's like a copyright protocol.
I'm not trying to record anything.
Okay.
Yeah, but, I just want to run this.
Sometimes it could be built into the system. That's what I'm because if it blanks like that, like it's obviously connecting and then come up for a second and then blank out. Sometimes.
See
if it goes
there we go.
See, and then it went out. That's the only thing I could see is it could be. You wouldn't happen to have a VGA to USB-C, would you?
I do not.
Take a look back here. I'm not sure if
sure.
I can do anything,
God. Is this yours?
Yeah.
Thank you, man. Saving the day.
Yeah, I would definitely, because if I had to guess, I can ask like our team to look into this afterwards, but I have a feeling that's what it is.
Make sure I give this back to you.
Are you playing any audio with anything?
No, I'm not.
Okay.
I'm just gonna.
Okay. That's really strange. Yeah, it's like a brand new room, so I mean, that's why I'm. Let's turn it back on and see.
I mean, who would ever expect new tech to work?
Right. Yeah, let's see here. And I would, yeah, let's see if it goes out.
Oh.
No, so it is a HDCP thing.
Okay.
All right, I'll have them look at it. Yeah, that's common. And
That's good to know.
when you try to hook up like a Mac via HDMI, it does.
Okay.
It shouldn't be built into the room system, though. I don't know why it is. But
Yeah.
I'll ask
All
them
right,
about
that'd be
that.
great. All right, it seems like we've about filled up here, and we'll be welcome everyone. For those new to CMU, welcome back to campus or campuses. We're going to be streaming this class to all 3 other campuses, Doha, Kigali, and in Silicon Valley. As you probably know, we're doing a little schedule change. We're not diving right into the material yet, but this is good because we're going to do a little bit of setup. So I hope this hour and 20 minutes can be sort of a hands-on tutorial back and forth. We have a bunch of TAs here working with me, and we're going to try to go around and help you guys get set up on AWS. So I'm going to give you a little bit of a background on AWS before we dive into the setup, and hopefully everyone will leave here today with a setup that they can use for all the rest of the assignments and have a productive development environment. All right. So what is Amazon Web Services? Well, it's one of many cloud providers. So they have a whole bunch of computers in some warehouse somewhere in the desert, and you can log in and get yourself resources, whether that's storage, compute, networking. So be it. We chose Amazon Web Services. There are many reasons for that. One is it's very popular. 2, we get a lot of credits for you guys. So that'll be helpful because deep learning, as you probably know, requires a lot of compute. Okay. So for you guys, you're going to only really care about 2 main services that AWS provides. The main one is EC2. These are just plain compute resources. It's pretty intuitive. If you already have a computer, you basically just get yourself a computer and you use it over the network. Later on, we're going to be working with some very large data sets, and you're probably not going to want to upload or download them over your local connection. S3 is Amazon's storage service, and if you figure out how to use this, you can use it to shuffle your training data onto new compute instances, and it'll be much faster, especially when we're dealing with hundreds of gigs of data. So there's a whole, once you enter the AWS world, there's a whole bunch of terminology and names, and you'll sort of figure these out in EC2 through these different things called instances, and these basically specify a configuration of the slides moving on your end. If you want to click the arrow and follow me along. I'm not good at multitasking. I've got to hit both. So you guys are going to be using some of the GPU optimized a lot, P2 instances. But one thing that you're going to learn fast is that AWS is not cheap, and you have a limited credits that you'll be given throughout the semester. So these all have different price points, usually billed by the minute or the hour. So when you're developing, you'll probably want to use something like a T2 or a C2, or some other lower end compute option. And then when everything's set up, there are no more bugs, and you're ready to train, then you can move over to T2. And we're going to talk about how to get those all set up. Yeah. So this is the spectrum of machines available. So if you're really that your model is amazing, you can spin up 64 CPUs and 732 gigs of RAM. All right. So one of the things that you're going to need to think about too is your development platform, and is your dependencies and other software. As you all know, one of the most time-consuming parts can be loading your software and making it all work. But the good news is AWS provides these things called AMIs, machine images. So intuitively, if you spin up a machine, you install stuff, you want to move it somewhere else, or you want to scale to more instances, you don't want to have to do that setup again. So you can save an image of your machine and reload it. But what's really powerful with this right now is there are a lot of community AMIs out there, specifically ones tuned for deep learning that have all the dependencies, different packages for different Python versions. They'll provide you nice virtual environments, so that way with one command, you can pull up a whole different set of packages. Say I want to run PyTorch in Python 3.6. You can simply do that using the Amazon Deep Learning AMIs. So today in the tutorial for setting up, we're going to load one of these AMIs. All right. Hopefully this is you've gotten a brief overview of what AWS is. If you weren't already familiar, now we're going to start. All right. So how many of you have your own GPU? Yeah, like, okay, 4 or 5. It's not a really sustainable game to keep upgrading to the next GPU. So AWS is a great way to also, as people with GPUs, you probably know it's tough to get everything set up correctly, installing CUDA drivers. This is all done for you on AWS. Also, on GPU is on this. It's great to build. So here are the steps. So everyone right now should go to aws.com, click sign in on the console. Here's some outlines. I'll get back to this slide, but I'm going to go through the step-by-step slides. And I'm going to wait for you guys and hopefully get some kind of consensus once we are through these steps. All right. So any TAs who are available right now can kind of walk around and see how people are doing. And just if you're stuck or have a question, just raise your hand and I'll come over. And then just look up when you're done. All right, so next this page is sort of like your EC2 dashboard, and it will show you all your different instances and your volumes. So volumes are storage blocks that you can attach to your instances. So say you write some code on your instance, you save some data, you save some output. You want maybe you're developing on a small instance, and you want to now move to a bigger GPU instance. You don't have to delete everything. You don't have to reset it all back up. You can just detach your volume, get a new instance, and attach it. So right now, just click on running instances. We're going to go through how to set up one of these P2 GPU instances.
Why do you want to be on the West Coast?
You just have to be consistent. So there's no specific reason. I think, yeah. So you can see this is Tom's account. Tom was a TA last semester, and he had a T2 micro stopped. He'd stopped using it. But if you guys haven't used AWS yet, and this is your first time setting up an account, you won't see anything here yet. And you can see below here, he has a pretty verbose description of all the aspects of the instance. So how many of you right now are just still signing up for an account? I don't want to blow past those people. Okay. Just a personal account. So basically, you will put in payment information, and as long as you have enough credits on board, you will not get charged. But the idea is that in case you go over, they will start billing you. Can I get a show of hands for who's made it here yet to starting an instance? Okay. We're getting there. Hold tight. So I think I'm going to move through some of these next couple steps, and then for those of you still setting up, I'll go back to the list of steps, and then we can go from there. All right. So the next thing to do is when you click, start a new instance, you're going to get this page first, where you can choose your machine image. You can choose from some of your own, or you can choose from a community-based one. Right now, we're going to choose from Amazon's provided deep learning AMI. Make sure it's the Ubuntu version. I just think that's a little bit more straightforward to use than the Amazon version, which runs on some other flavor of Linux. So just select that, and then you're going to get this long list of different instance types. There's not too much description here in terms of price. I think that is purposeful, that they don't give you that when you're selecting it. So also make sure that whenever you pick one, just do a quick look, Google the instance costs, and you can see them per hour, and do a little calculation and see what you're dealing with, and look at your credits. So right now, go ahead and select the P2X large. This is going to be a little bit more expensive, but we're going to shut it down right after this. So. All right, so the next step here, these are a bunch of details for the instance. You can have more configuration. You can specify this thing called IAM role, which is a security protocol, like what services can have access to this instance and whatnot. There's not too much to worry about here unless you want to customize more, or if you want to, you can change the number of instances that you want to launch in one go. So just kind of move past that one. So one thing about the deep learning AMI, because of the amount of software on it, you're going to need to have at least 75 gigabyte volume allocated for the instance. But later on, when you're going to be dealing with, data sets that are hundreds of gigs, you're going to have to up this number considerably. And then I would also suggest looking at pricing for volumes. So that's actually through a different service. So you're charged for compute hours for a compute instance being running, but you're also charged for how long you have a volume allocated. So a lot of times when you stop an instance, the allocated volume will still be there. So pay attention to that too, because people will stop their instances, think they're good, and leave their volume sitting around for a year and have that rack up some charges. Yeah, so we're not going to use tags, so you can just skip this one too. So next is the security groups. This is going to define how people can access your instance. So if you guys are trying to build a really secure web service, I would not suggest doing the security measures that we're going to take. But basically, what you can do is open up port 22 to the world. So this is the default port for the SSH protocol. If you have other services that you want to run, specifically Jupyter Notebooks, those have a default port, I think, of like 8585 or 888, 848s. And you can also specify a rule to forward traffic to your instance through that port. So now quickly, just review, do a quick sanity check, and then hit launch. And this is what's going to happen to you. You're going to have a launch failure. This is purposeful. So Amazon doesn't let anyone just spin up a GPU. Basically, you need to go and get access granted to you for your usage. I think these are just because Amazon has a limited number of them. So I'll get back to how we solve this problem. But right now, I'm going to go back to the overview. And hopefully we can get everyone up to speed here. Can I just get a show of hands of people who have launched the instance yet?
I've got some dialog out saying select a keypad.
A what? Keys. I don't think I went over that. So where's that slide? All right, that slide may have gotten eaten up by something. All right, so there's one other step. It's not reflected on the slide right now, but basically what it is that you're going to need to configure a private key to access your instance through SSH. Amazon will generate you one. Don't lose it. If you care about that instance, you can always generate a new one, but you will never be able to get back into the instance that you've configured, that you've chosen the key for. And then once you create a key and you create more instances, you can associate those instances with that same key and keep it safe on your drive. Change permissions. It'll actually give you, when the dialog pops up, it will give you all the different steps that you need to take. I think you need a chmod 400, the key file. That way it's protected. And then when you SSH in, you can then use that key to SSH with. And it'll show you the command, but it's SSH-I, the path to the private key file, which has a suffix .pem. We almost had a laptop destroyed. So path to that file, and then it will log you in. I'll go back to the overall steps.
Can I go previous page?
Sure. Yeah. Wait, sorry, say that a bit louder. Oh, the credit? Yeah, so you're going to get 150 over the semester.
So this was not the total.
This was a $50 credit.
So we have to use the Andrew ID to create the account on the Amazon.
I don't believe you do. You don't have. This can be any account, any Amazon account, because you'll put the credit in anonymously. It's just simply a promo code. Okay, let's do another show of hands. Who's launched? Yeah, sure. So the machine type is going to be a P2X large.
Is there any specific reason why we're not using the latest P3 instances?
I think those just came out like a week ago or something. Right? Did they? I mean, I don't know. I've actually haven't heard about it. But yeah, you feel free to use whatever instance type you think will be more advantageous. What's up?
Launch failure.
Oh, launch failure. What's the?
It says we have requested more instances, quote one, than your current limit of 0. It seems that my current limit is 0 instances.
Is that GPU? Is it this error? Sorry. Is it this one?
Yeah.
Exactly. Yep. That was meant to happen. So just hold tight. I'll get to how to resolve that. Sure. And you guys, if anyone's stuck on anything, just raise your hand. So one of the TAs will come around. Yeah, sure. Raphael. Sorry. Do you have questions? That's actually fine. Yeah. It's just an error that happens. I think it's for if you're a non-business. So the free tier is for anyone who's in personal use. So it's actually fine. Just go ahead and launch. You're done. Just wait right there. I'm going to go over what happens after that failure, how you can solve it. What's up? Okay. I'll send, let's see. Once someone's available, they'll come right over.
I was trying to log in to the AWS account and it asked me my credit card number. Is that almost?
It is. Okay, yeah, I'll do that. For your account itself? Okay. These slides will be posted afterwards. So, yeah. Okay. So the question is it okay if you don't use AWS Educate? Yes, you don't need to. Only benefit is AWS Educate could give you extra credits. I believe last year at least it was 50 credits on sign up for AWS Educate. You're gonna want every extra credit you can get. So if you use AWS Educate before, yeah, so like if you sign up your account through them, and you've used those credits, we're going to give you extra credits, but it's just more credits on top of that. So then you can actually get $200 of credits in total instead of 150. We're going to give out 150. And for those of you who are done setting up, check with your neighbor and see if they need any help finishing the process up. All set? Oh, the next one? Okay. It may have changed. Oh, no, this is the Amazon Linux one. You need to find the Ubuntu one. Yeah.
There's a bunch of like the deep learning AMI choices.
It's the deep learning. So the question is which AMI instance is it? And the answer is it's the deep learning Ubuntu version. So if you just search in the community marketplace, search, it'll say like the tab is community AMIs, and then you can search deep learning, and just the deep learning Ubuntu Amazon AMI. The AMI. So the question was, do you need a specific version for the AMI? Not exactly. You should look in the details and see like what versions of software packages that you're most interested in. But I would suggest just taking the latest stable version if they give an indication of if it's stable, or the latest version if that's available. So you're going to have to create a key. This is what I was discussing before about like you're going to need a key personal to you to access the resource. So it's going to create a key, and it's going to give you a file, and you're going to use that to sign in.
ready, but so I was in the launch failure page, right?
Yeah.
And then I went back to the home page.
You're good. You're good. I mean, it failed, and it failed. I'll show you how to fix that. Yeah. Create a new one. Yeah. All right. I'm going to keep checking in. How many people have launched now? Okay. Okay. We're getting there. A couple more, and then we'll move on a little bit. Here you want. Can you go and post the slides?
Yeah, that's what I asked on Slack because I don't have the rights for the website.
Oh, no, just post on Piazza.
Oh,
Just,
yeah.
Just do that, and then I'll tell people, because then we can keep going, and they can then do the finish. It's up, Piazza. All right, so I'm going to move ahead right now, but these slides are on Piazza currently. So if you're still getting set up, I'll keep going and you can keep listening. But if you need some details back here that I'm going to move past, you can reference them there right now. All right. So for those of you who have launched and received this failure or expect to receive it soon, basically what this is saying is that Amazon's not going to grant you a GPU yet. So you need to go in and figure out how to request access. So go to this link, which is also provided in the error message. And then however many instances that you think, well, I'll tell you, you probably need only a reasonable number. I would not go up there and say you need 100 instances, but maybe 2 or 3 or 4 will do. I mean, in most cases, you will only need one, unless you want to really coordinate a more distributed training system, which I would recommend doing. So I would recommend allocating 2, 3, 4 GPUs, and basically Amazon has pretty good customer service. Like someone's actually going to go look at your request. So it's not just a bot. Give them a good reason, mainly that you're a student in this course and need that number for the remainder of the course. And even if you ask for this many GPUs right now and it's a wrong number, like you may need more later on, you can always go back and request more. And as I found, they'll usually grant it. And this is going to take you a couple days, so it's good that we're doing this now. And then hopefully by the time you'll start training, the permissions will be granted for you. So this is the screen that you're going to see when you follow that link. And just once again, if you've selected the Oregon region or like US East or whatnot, make sure that that's the region. We used P2X large, and then just the limit is the number of P2X or GPU instances that you're requesting. And I think someone asked before what about using the new P3 instances. So for example, I'm assuming those are going to have the same kind of restriction on GPU usage. So if you want to get a limit increase on that type of instance, you'll have to do a separate form. But using the same link, you just change the instance type to P3. So to get to this page, just follow this link, AWS, Amazon.com, contact us, EC2-request. So the question was, is the limit type EC2 instances? So are you talking about this entry? Yeah, okay, just P2, whatever instance type that you want to increase your limit on. And then right below that is where you're going to put in your sob story for why you need multiple GPUs. So the question is, you increase by 5. You asked for 5, but increased by 1. Did you put in so your request was for 5, and how do you know that you've only been granted 1? Did they send an email back? Yeah. Oh, interesting. All right, I'll go look into that and see what we can do. So show of hands, how many have filled out the request? Okay. All right, so if you still need to do this, this will be on the slides on Piazza. All right, so this is sort of the one big warning of the semester. So last semester, when we ran the course, many people went over budget. So definitely know your costs. Find those sheets and just do a quick mental calculation of how much it's going to cost and like how much you want to run for. So there are two terms to know here. There's stopping an instance and terminating an instance. So stopping an instance is just like suspending it. The instance is not shut off. It's still configured and whatnot. Terminating it will blow away everything on it, and it will also delete the volume as well. So make sure that if you've developed code on your instance, don't terminate it before you pull that code to somewhere safe. So if you haven't done this already, we're going to show you how to redeem your credits. So for everyone, I believe, who was registered for the course before August 15th, you will have gotten or should have gotten a AWS credit. For those registered after, we had to request more, and they're on their way. So for those who registered before August 15th and haven't gotten a credit yet, can you raise your hand? All right, that worked. Okay.
I have a question.
Yeah.
You had mentioned about volume being still in use. So if we stop the instance, will the volume be stopped as well? Or that has to be then separate?
So the question is, if you stop the instance, will the volume be stopped? Well, the volume is just a block of storage. So
For the storage, if your system is stopped.
yes. Minimally, it's not that, but we'll definitely look at the cost so you have an idea. All right, we're back online. I was talking about, so yeah, the way I would recommend developing on this is have a Git repo with your code. You can develop on there, push it up, and then if you ever want it, you can just terminate your instance, get a new instance, and just maybe have a script that pulls all your repos and sets up your local system.
Which is the phone options on the contact, and I just receive a call.
So the question is, there are multiple contact options for support. Whatever one is best for you, whether phone or by email. All right. Okay, so here's a little bit on stopping the instance. You'll see it. So for those who it's failed right now, you will not see an instance there, but you will get an instance here, and you can click on Actions and change the instance state. And like, I'm gonna talk about a. What's up? It stopped again. Okay. Streaming is fun. All right, we're back up. Oh yeah, so later I'm going to show you guys a way to like automatically launch instances, and it also has a teardown feature that will terminate your instances as well for you from the command line. This I found is not always consistent, so I would always recommend when you're done using your instances to come back to this page and just make sure that they're all stopped. Because there's nothing worse than having fun on the weekend while your instance is churning away, charging you cash. So just so you guys can check out your credit level. So under billing, dashboard, credits. And this will bring you up to the credit redemption page. And you can enter in the program code, do the security check, and it's as simple as that. And you'll see a little list here with all your different credits. Specifically for this class, you'll get 3 credits, each $50. So you will see those listed here. So you'll ultimately have 3 things listed, and then if you're using Educate, you'll have another credit for $50. I think that's the current deal. It's 100. Great, it's 100. Yeah.
You get somewhere between 50 to 150. It's not fixed. Like,
Really? They probably use deep learning for that. Okay. So after you've redeemed your credits, you've asked to have your GPU allocation increased. Now we can talk a little bit about actually developing on AWS. So developing remotely can be kind of a pain because if you lose your connection, I mean, anything stored on the disk is not gone, but any of your current context of your environment will be lost. So one way to do this is to use Tmux. There's another tool called Screen. Both work equally well. Tmux has some other fancy things that you can do, such as screen splitting and whatnot. So use Tmux. You can open a shell, save the state of the shell, exit the remote connection, and then sign back in, and then reattach the shell, and it's as if you never left. So come back to this thing if you want to try using Tmux. I think it'll be useful. Or ask me if you want to use a letter rate option, or look it up. It's called Screen. So it's another Unix utility. All right. So S3 I talked about before is Amazon's storage service. So for now, you're not going to find it as useful, but later on when we're going to use some very large data sets, this is definitely going to come in handy because it's within the same high bandwidth network that your instances will be hooked up to, so transfer times will be really fast. Yeah, so definitely read these introductions to S3. All right, so I'm going to wait a little bit because we're just going to move on to a last little section here that doesn't have as much to do with AWS, but I just want to do a check. Who has launched, submitted the request, and redeemed their tokens? Can you raise your hand? Okay. Who is still waiting to launch right now? Okay. Who's still sending in the form? Okay. Okay. I'll wait another couple minutes, then I'll start. All right. So hopefully people are mostly there. Slides are up. Use them to finish the setup that we just discussed. Okay. So right now this is a bit of a preview for what's to come, but I hope this will be useful for you. So an idea is how can we, as we develop deep learning software, we're going to need you're going to realize there's a massive compute bottleneck. and not even just for a single training time, but for trying different network configurations, trying different hyperparameters. You're going to need a lot of compute, and there's a lot of time spent setting up the training system. And many companies nowadays have found lots of success of building large distributed systems to speed up their training times and speed up their development through this parameter exploration and architecture exploration. So right now, what if we, as developers, can have the access to launching our own distributed training systems very, very simply, without needing to worry about a specific system configuration or resource requirements. All right, so this is where Ray comes in. So Ray is a pretty recent project out of Berkeley. It is a distributed execution framework, and specifically it has been tailored for machine learning computation. So basically, instead of thinking about a set of instances and whatnot, all you have to do is you can specify any number of machines and whatnot, and then Ray will only think about it in terms of resources, the number of CPUs and the number of GPUs. That's all you can care. So you can set up a cluster with, machines of different types with different properties, different numbers of CPUs, different amount of memory, different numbers of GPUs on different nodes, some without GPUs, and Ray will help schedule parallel tasks on these resources in the most efficient way possible. And you can write everything in a Pythonic declarative manner, and then Ray will take care of the scheduling, the serialization of data between these different parallel processes, and other communication, and it will also deal with different data dependencies. So, for example, if you produce some data on one node of the cluster, it will schedule away a more efficient way if another process needs that data somewhere else in the cluster, and it will deal with that for you. Okay, so here's an example of a very simple setup that you can imagine. So the idea with Ray considers one machine to be the head node, just saying, n CPUs. Let's just say each node has a GPU, and then every other node is considered a worker. So here's a little simple example of using Ray. This is how simple it is. So imagine we have two functions. One of them we're going to decorate with this thing called @ray.remote. And what this is going to tell us is that if we run the function F1 locally, so we always run on the head node, F1 will run on the head node, and we will sleep for 1 second. But if we run, so this will take 10 seconds because it's guaranteed to run serially. But simply if we call F2.remote, each time it will actually, Ray will then schedule that task on whatever resources it's provided. So we're assuming here that the system has at least 10 CPUs, and this is very, very ideal scenario where there's no descheduling or swapping out, and they're going to run in parallel. And then ray.get will then collect the actual result of the function, independent of where it was executed. It could have been executed on a machine in Oregon, and ray.get will bring it back to you. Okay, we're back on. So the way that Ray works here, this is sort of subtle, is it deals with object IDs instead of objects themselves. So you can do a whole bunch of computation just passing IDs to functions, and those will execute remotely, and you don't even need to have the data shipped back to you yet. So that's to reduce bandwidth and also to allow the scheduler to define a more optimal passing scenario. So we take X, which is now an ID, and we call F on it again. Now it's Y, and then we then call F on Y again to Z, and then we get Z at the end. This was 3 invocations of this function. These could have been run on any part of the cluster that we've registered to Ray, based on whatever was most optimal. And at the end, we just told Ray to retrieve the object, but we didn't specify at all how the object will be passed around remotely. All right, so ultimately, what this is leading up to is that Ray also allows you to automatically configure AWS clusters and by clusters that can even just be one machine automatically through a simple configuration file. So you won't even need to really deal with like using the AWS console unless you're checking for things that are stopped. It'll be a one command ray up, and it will create your cluster based on your configuration. And Ray can also see when utilization is reached, and it can automatically scale and launch more workers for your needs. So later on, when you guys are using tuning, by getting used to Ray right now, I think it will save everyone a lot of time and be really useful, and maybe even save money, because at the end of the day, it may be faster to spin up many expensive instances for a short amount of time than a couple for a long amount of time. Okay, so it's pretty simple. Just use a simple pip install, and then after that, we need to get AWS set up on your console. So to do this, you're going to need to update your IAM user. This is just an identity access management user, and you're just going to create an access key, and it's going to generate these two long strings. And just make sure you keep these things private and safe. And I believe you can find the IAM console right in the AWS dashboard. While people are doing this, does anyone have any questions about Ray? So you're saying there's no IAM user yet? Okay, create a user.
We also create a group. Do we add the user to a group, or do we attach existing policies directly?
So in this case, I don't think you're going to need to attach policies for your given user. That's, I think, if you're trying to integrate other AWS services. create a new key.
No, it already created one when we created the users. So should we create a new access?
No, as long as you have that, then you're good. So the question was, when you create a new IAM user, you'll already get an access key, and if it's already created for you, then yes, you can just go ahead and use that.
So when I'm creating a new IAM user, is it okay if it says this user has no permissions in the last step? Or,
That's a good question. What are the options?
none. Just says this user has no permissions. That's thanks because we didn't like add it to a group or anything or attach anything to it. Like is that okay? Or does it need to have something?
Yeah, so I believe that, yeah, you may have to attach like a all access policy then to it if you want to be able to use all of your AWS services. So that's a reversal on what I just said before. Okay, so the question was, when you create your user, do you have to attach, add it to a group or attach a policy to it? So basically, what you'll need to do to grant it permissions to use EC2 and other Amazon services is you'll have to attach a policy or add it to a group that has access to those services. So I believe there should be a EC2 or an all access policy listed there already. And then I can post a follow-up if people are still stuck on that with an example.
Is Ray something we install on our instances that help us manage our resources?
So the question was, is Ray something that we install on the instance to help us manage a cluster? So you can use it anywhere. You can use it on an instance, and actually Ray will run locally. Ray will just schedule processes local to your machine. But the way that we're going to go through it is that you install Ray locally on your computer, and you.
If I use a Windows machine, so I need get a virtual environment like that.
I see. Okay, so the question is, if you're on Windows, one thing that you can do is, yeah. So that gets a little bit tricky. Yeah, Ray may not support that, but if you have a virtual Linux thing going on, then you can definitely use that because it will spin up a cluster on AWS and it will launch you into the head node, and it will actually load Ray on and register all the nodes that you created. But you would need some kind of Unix tool to do that from.
We install Ray locally, so which helps us determine how many instances or how much resources.
So the thing is, you install Ray locally, and you can then use Ray to then it has a utility to manage your EC2 instances. So you spin up a bunch of them, and then Ray will initialize nodes on each of the instances. So in the basic use case, you can simply use Ray to just launch and tear down your cluster. That's where I think it's useful to everyone right now. It's just a simple management utility of managing your instances. The second use, which I think will really come in handy soon, and we're going to go through it in further recitations, is that once you have multiple instances, you can simply use Python and say, all right, I want to run this task. Say I want to train, I want to run inference, and if you run it 10 times, it will then, if a CPU is busy, it will know where all the other CPUs and GPUs are, and it will then schedule that task out without you doing anything, and it will schedule it efficiently. And it will already be set up if you use the utility to launch your instances.
For now, it's just a shortcut. We don't need to use the control panel anymore. We just use Ray.
Exactly, yeah. Yeah, for now. Okay, so I'm just going to show of hands who is done with this, getting those credentials.
So when you're creating an IAM user, what permissions do you need?
Whatever the permissions are for like being able to access EC2.
Amazon EC2 full access.
Yeah, that's a good one. Basically, the way that AWS tries to deal with security for applications is they specify these things called policies and roles. I forget the inheritance of them. One has the other, but basically policies determine like what different services something has access to. So for your user, I would just give it administrator privileges over whatever service that you want to use. So for example, we're going to use EC2. So give it, you can search, it'll have a whole thing. You can search EC2 access. All right, there's another option. If you create a group, you can use admin all, and that should give you full access to. Okay. So I'll say it again, but I think the answer is, I think you can re-download it. You should be able to get it again. But then, all right, so basically, if you delete your old access key, anything, I just think it won't be valid. Yeah, I would just look that up. I doubt it'll have serious problems. I would just only be worried that you may not be able to get into something that you had access to before. Like if you've registered that user for something else. Yeah. Okay. So we're almost at the end here, so I'm going to keep moving on. These slides will still be up. So once you get those credentials, you're going to need to install 2 Python packages. One is AWS CLI, which is the Amazon command line interface, and Botto3, which is another command line package. Both these are actually useful packages if you want to manually manage your Amazon AWS services through the command line. There's great documentation on these, so this is also useful if you don't always want to be poking around in the console or want to automate some workflow. But next, when you install these, they'll create a configuration folder called .aws in your home directory. Create a file called credentials, and then basically add this, and then replace the brackets and these placeholders with your access key ID and your access key secret. Sorry? Yeah, so the question is, why is the first line default? I don't know, but that will make it work. Yeah, just add that line. I'm assuming it's another configuration that you can use to specify more keys. So if you install those packages, is it not there yet? Okay, so you may just have to create it, and it will look there. Sorry? So the question is, when you add your access key ID and secret, do you have to take away the square brackets? The answer is yes. So the question is the .aws directory created, or is it already there? The answer is, it seems like, for me it was created, but for others it's not. So just go ahead and create it if it's not already there. So once you guys have that done, the next thing is to use a template for launching the cluster. So these are just simple YAML files. I've written one up and based on one of Ray's templates, and I've added it to our tutorials repo, which is like this fall 2018 in the CMU Deep Learning GitHub. So I think if you just look up CMU Deep Learning on GitHub, you will find this repo. You can go in there, look in Recitation 1 directory, and you will get this thing called dev template YAML. And so now what you can do is you can copy this dev template into a file called dev YAML, and then you can edit it, change it however you want it. It's pretty intuitive. You can see like change the number of instances you want to set up, the instance types, the different kinds of AMIs, the region that you want to launch them in, etc. You may have a problem right now with the region. I think the region may be set to US East, but if you're using Oregon, then you can set it to US West. And then to launch these instances, it's just as simple as running, once you've installed Ray with pip install Ray, you can then run Ray creator update dev.yaml, and it will actually go ahead, launch your instance, and you can actually specify setup commands in the YAML file. It will run those commands on the instance that's set up or instances, and then it will actually give you a command to log into the cluster with. We have one more minute, so I'm just going to finish this. So basically, once you're done, you can then run Ray teardown on the same file, and it will go in there and try to stop your instances. I've had issues before where it actually won't stop the instance, so I would definitely go back into the console and just make sure that it's shut down. But that should be the only console usage you would need. Yeah. All right, so think we're about done. These slides will be up in Piazza. We'll be on Piazza to answer more questions. I know there was some confusion around groups and access IDs. I can clarify that more. So I'll probably post another example. This will be recorded and up on YouTube afterwards if you want to go back through. And lecture 1 will be as usual in here on Wednesday. Lecture 2 will be in the recitation room on Friday. We look forward to seeing you guys there. Thanks again.